So to think about how we do u-substitution, let's think back to the chain rule. The chain rule we had the the outside function and the inside function, and now we'll still need to spot what's outside and inside, and we also need the derivative of the inside function to be a factor that's multiplying the outside function kind of from taking the derivative, so that when we take the antiderivative, it's there kind of when we need it. So if I had cosine of 3x times 3, what would you say is the inside function? You'd probably say it's the 3x. What's the outside function? You'd say it's cosine of the 3x, or you could say cosine of stuff, and that 3x is the stuff, right? And then what's the derivative of the inside function? You'd say 3x prime is just 3, and lo and behold, there's a 3 sitting right there. Isn't that handy? So that derivative of the inside is already multiplying the outside function. What if we had the more complicated example, e to the x squared times 2x, which you could also write as exp x squared times 2x. What's the inside function? What's the outside function? And what's the derivative of the inside function? You'd say the inside function, maybe it's more obvious here than there, it's x squared. The outside function is e to the stuff, or you could say exp stuff. And inside's derivative is 2x, which, wonder of wonders, is sitting right there. Now, the key idea here is that the outside function, if this were taking the derivative, we might be tempted to say the outside function is e to the stuff times 2x, or we might say, well, that's even product rule, let me just deal with e to the stuff first. So here I'm not saying that the 2x is included in the outside function. I'm saying it just kind of happened to be there because, and that happened to be the derivative of the inside function. So here we'll say not e to the stuff times 2x. The 2x is kind of a separate thing, not considered part of the outside function. Okay, so it sure was handy that I had a 2x there, and it's handy that I had a 3 there. What if I had only had an x here? You might say, well, I'm going to be off by a factor of a half. And that's true. So we do want the inside function, derivative of the inside function, to be a factor multiplying the outside function. But it's okay if we're missing a constant factor, because we can adjust for that later. So we'll write that down. So let's do a formal version of this using the letter U. So the inside stuff, we're going to call it U. So if I have integral, let's say, of e to the 5t dt, we could say, what is the inside stuff? So instead of saying inside equals x squared or inside equals u squared, inside equals t squared or something, I'm going to say u equals 5t. That's my way of saying what the inside stuff is. And the outside, let's try that again, is e to the stuff, or e to the u. And then here's this thing we weren't worried about up there because we weren't writing integral signs. But now that we have an integral sign, we have this dt. What are we going to do about that? Can I just change dt to be du? Can I just write a u instead of a t for dt? Well, we have to think back to chapter 4.4, which was about differentials. In that chapter, we said if u equals 5t, then du equals 5t prime times dt. So du equals derivative of 5t is just 5 dt. So I can't just say du and dt are the same thing. They're different by a factor of 5. So I can't just replace du with dt. What I have to do is, well, can I just substitute here? Almost. I almost know what dt is in terms of du. What I can do is divide both sides by 5, so I get 1/5 du equals dt. And that tells me, hey, anywhere you see a dt, you can replace it with 1/5 du. So I can take this integral and say this is the integral of e to the, and I can replace 5t with u, so integral of e to the u, replace dt with 1/5 du. What's that integral? What's the integral of e to the u? It's e to the u. And then I still have 1/5 because of the constant multiplier rule. Plus c. Am I done? Well, if your boss said, I need this integral, what are the chances of that, right? But if they did, and you came back and said it's e to the u times 1/5 plus c, the boss would say, what is u? I gave you an integral in terms of t. T is in seconds, maybe, and u would be in fifths of a second or 5 seconds or something. They might say, I want it in terms of my original variable. So let's substitute back to get the original variable. With u equals 5t. So now anywhere you see a u, replace it with a 5t, which is the opposite of what we did before. So we'd say this is e to the 5t times 1/5 plus c. So that's our systematic way to kind of handle the chain rule, or the opposite of the chain rule, inside an integral. Let's check it. What is e to the 5t times 1/5 prime? That's e to the 5t times 5t prime for the chain rule, times 1/5 for the constant multiplier rule. So we get e to the 5t times 5 times 1/5, or just e to the 5t, which is what we were integrating initially. So we're good. So on the homework, when you're doing these indefinite integrals, it's important to check when you get a final answer. Part of your evaluation could be, or often would be, taking the derivative and making sure you get back to this, get back to the integrand that you started with. You don't have to be super exact. I mean, you should be exact. You don't have to be super wordy about it. You can take little shortcuts in steps like this that I'm not taking here, just because I'm trying to show the full explanation of what's going on. Let's try it again in the next video.